All right, let's get into it. Today, we're going to tackle a tool that's absolutely fundamental for any C programmer, the one-dimensional array. This thing is like a secret weapon for turning total data chaos into clean, organized code. So let's dive in. First up, let's talk about a problem that I guarantee every single person learning to code runs into. I like to call it the data clutter problem. Okay, so imagine this simple task. You need to keep track of the high temperature for all 7 days of the week. With just the basic tools you already know, how would you even begin to approach that? Well, your first instinct might be to just create 7 different variables, right? You'd have temp1, temp2, and so on. And while, this technically works, you can already see how messy this is getting. Just imagine trying to track a whole month's worth of data or a year's. It's inefficient, it's a total nightmare to manage, and it just doesn't scale at all. Luckily, there is a much, much more elegant way to handle this data clutter. And that solution, my friends, is the one-dimensional array. So what exactly is it in technical terms? Well, as you can see, an array is a data structure that stores the same type of data in contiguous memory. Now, that first part is key. You can't just mix and match integers and floats in the same C array. And contiguous memory, that just means all the items are stored neatly, right next to each other in a line, which makes accessing them incredibly fast. The best way to think about it is like this. Instead of having 7 separate, messy boxes scattered all over the place, an array organizes them into one single, neat, connected row. It's kind of like a pill organizer for your data. One container with perfectly labeled compartments for each day of the week. Now, to use this incredibly powerful tool, we just need to learn a few simple but absolutely critical rules of the road. First up is how you declare one. Looking at the example, int grades 5, we're telling the computer 3 really specific things. First, int means we're only going to be storing integers. Second, grades is just the name we've decided to give our container. And third, that square bracket in the square brackets tells the computer it needs to set aside space for exactly 5 items. Now listen up, because this slide shows the single most important rule you have to remember about arrays in C. Indexing, which is just how we get to each box or element, it starts at 0, not 1. So for our array that holds 5 grades, the very first element is grades 0, and the last one is grades 4. This trips up literally everyone at first, but it is absolutely essential to get it right. Of course, an empty container isn't very useful, is it? We need to actually put data into it. You can initialize an array right when you declare it by just providing the values inside these curly braces. Just like that, we've filled all 5 slots in our grades array from the get-go. And check this out. This shows a really helpful little feature in C. What happens if you say your array has a size of 5, but you only give it 2 values? Does it throw an error? Nope. The C compiler is smart. It fills the first 2 spots with your numbers, and then it automatically initializes all the rest of them to 0. It's a very handy thing to know. Okay, so we can store data neatly. That's cool. But the true power, the real superpower of arrays, gets unlocked when you combine them with loops. This is where they stop being just a simple storage box and become a dynamic tool for automation. Let's go back to our grades array. If you wanted to print every single one of those grades on the screen, sure, you could write 5 separate printf statements. But again, that's not efficient. What if you had 100 grades or 1,000? No way. There has to be a better way. And there is. The for loop is an array's best friend. I mean it. If you look at the code, we create a little counter variable, I, that starts at 0 and goes up to 4. And in each pass of the loop, we use that I as the index for our array. So it prints grades of 0, then loops again and prints grades of 1, then grades of 2, all the way to the end, completely automatically. It's clean, it's powerful, and it does all the work for you. Okay, let's take it a step further. This amazing combo isn't just for printing. Using that same idea, how would you calculate the total sum of all the grades in that array? The logic here is actually pretty simple. You start with a variable for your total, and you set it to 0. Then, you loop through the array, just like we did before. But this time, inside the loop, you take the value of the current element. That's grades I. And you just add it to your running total. When the loop is all done, your total variable will hold the sum of everything. Simple as that. Now that we've seen all the power and the glory, we have to talk about the dangers. Arrays are fantastic, but they come with a few common traps that are just so easy for beginners to fall into. Here are the big three. The most common one by far is the out-of-bounds error. That's when you try to access an index that just doesn't exist, like grades 5. Second, if you forget to initialize your array, it can be filled with random leftover garbage data from whatever was in that memory before. And finally, getting your loop conditions just slightly wrong can cause you to miss an element, or, you guessed it, lead to that dreaded out-of-bounds error. And this slide right here shows the classic loop mistake. On the left, see that I less than equal to 5? That condition will cause the loop to run one last time when I is 5. But remember, our last valid index is 4. So the code tries to access grades 5, which doesn't exist, and that can crash your program. The correct way, on the right, is I less than 5, which makes sure the loop stops right after it processes index 4. That tiny little character makes all the difference. So, let's recap the most important takeaways here. 1. Arrays are for storing collections of the same data type. 2. Remember the golden rule. Indexing always starts at 0. 3. You unlock their true power by pairing them with loops. And finally, number 4, always double-check your loop boundaries. If you can get those 4 things down, you've pretty much mastered the basics. You know, we've seen how fantastic arrays are for organizing numbers, things like grades and temperatures, into these neat, accessible boxes. But that kind of leaves us with a fascinating question, doesn't it? Can we only put numbers in these things? What happens when we want to store and work with text? Now that's a topic for another time.